Bit of an unexpected video this one. Whilst waiting for parts for my current project to arrive, my editing speakers have died. They're these Presonus Eris 3.5 Gen 1 jobbies. I was in the middle of editing a video and the sound kind of fizzled out. The blue LED, because every device has to have a blue LED these days, just sort of faded away, and no amount of switching them on and off again would bring them back. I even left them on overnight to see if there was some kind of thermal cutout, but no joy there. Now, these aren't particularly expensive as audio monitors go, but because I'm very limited on funds at the moment, whilst I'm trying to get the funds together for doing the garage conversion, I thought we'd open these up, see if we can see what's wrong, and see if we can bring them back to life. And we're going to do that, you guessed it, right now.
Mark fixes stuff.
Need a project done quickly? Well, PCBWay can whip up and ship boards before you've even had time to clear your workbench. Go over to PCBWay.com and put your order in today. And thanks to PCBWay for sponsoring this video. As if I clear my workbench.
These are the first generation of this model. They've been okay sound-wise, and have tuning pots for the acoustics on the back. There's a main unit which holds all the electronics, and the other speaker is just a passive, aka a speaker in a wooden box, connected via the red and black speaker wires. AC power is supplied via an IEC figure of 8 cable. That means the AC is internally turned into DC. And that means something in here is going to be generating heat. The way that the speaker died gave us a clue, because they were in use when the sound kind of petered out and the power LED faded. This suggested, to me at least, that there was a power problem. I've already checked the fuse and tried another cable, but I'm pretty sure it wasn't the power input anyway. Okay. Let's get this open and start investigating. I don't want to scratch up the front of the speakers, so let's lay down a cloth. The screws holding on the back panel are a kind of a chipboard screw, so you probably wouldn't want to be removing and replacing these too often. That being said, it's a fairly common type of arrangement with speakers, and they've certainly used enough. With the screws removed, we can carefully take the back off of the main unit. These speakers died exactly 3 years and 1 month to the day after I bought them. Inside is a bit of a disappointment. I genuinely wasn't expecting much, but for a set of small speakers costing a bit over £100, I was really not prepared to see these low-grade, no-name capacitors. Well, maybe that's unfair, because they do have a name, Cap Top, and try finding out some details about them. Inside the speaker box there's a loosely packed wrap of sound insulation foam, literally just poked inside. If we look closely, we can see where the power switch is, and it's glued in. There may also be a couple of capacitors up the front, but they won't be affecting power on, so I think I'll try and avoid breaking those out. We can always revisit them if there's a further problem. I am making a note of where these cables connect to, but they're fairly obvious anyway. The level of fluff in here is absolutely wild. I haven't seen fluff like this since the 80s. Strangely, the build quality feels quite decent, despite the utter crap components that have been used. So here's the board. Even before our inspection, I can see it's going to take a bit of work to separate this from the back plane of the speaker. So what do we have? The biggest item here is this wire wound transformer, which tells us there's a lot of AC to DC conversion happening. Over here we have a TDA 7265 stereo audio power amplifier, and attached to the same heatsink we have an SVF10N50F MOSFET. More heat. And with this heatsink chucking out all those therms, crap capacitors don't stand a chance. My immediate suspicions would be here. And already I can see a likely suspect. One of the dead giveaways that a capacitor has thrown in the towel is when the top starts to bulge like this. Normally they're as flat as a pancake, but once the internal pressure kicks off, they have a tendency to become domes. The bulge is basically trapped gas from the capacitor's fluid breaking down. Most electrolytic capacitors have vents scored into the top, which are designed to open up if the internal pressure gets too high, rather than letting them burst all over the board. We've been lucky, and that brown material is actually potting, which is a kind of glue. I've made a list of the capacitors that we'll need. Unfortunately, it's slightly wrong, so don't copy this if you're watching this video. I'll update this list, make a copy available and link it below. And a big shout out to this eBay seller called Techie Kid. Look at the quality of this packing for one capacitor. I like that. I've gone out of my way to get branded capacitors here. I'd really like to put things in that will last and are properly rated for 105 degrees C. So we need to liberate this PCB. To get to the underside of the board, we're going to need to take some parts of the back panel off. We'll also need to work out how to remove this foam, and hopefully we don't need to cut it. The main way that the board is connected to the back panel seems to be through these standoffs, which are attached by these screws. These two screws mount the speaker output, so we don't need to remove those. And I'm not sure about this one. We will need to remove these though, because these hold the jack sockets into the metal back panel. I'm just giving them a twist with a pair of grips. And once they're off, and we remove the washers, we should be able to just pull those through the panel. The tuning pots have two plastic knobs which just pull off. I'm quite good at pulling these off. I'm still not sure if this screw needs to be removed, so I'm going to leave it for now and see if I need to pull it out later. Because of the massive amounts of epoxy resin, I've decided that we need to remove the standoffs from the outside of the speaker shell, and that means we'll just leave these attached, but that shouldn't be a problem. They fix straight in with these machine threaded screws. Some of the standoffs are plastic and some of the standoffs are metal, so another advantage to leaving them attached to the board means I'm less likely to get them mixed up and inadvertently ground the board to the outside of the speaker. Once we've got the board free, we'll be able to remove all those capacitors and change them. And because we don't know if that visually blown cap is the only dodgy capacitor, I'd be more comfortable replacing them all. In order to see what's failed afterwards, we can test those capacitors with my ESR meter. And when we do that final test, we'll be able to see if they've got high resistance, which would block the power to the speaker. The kiss of death for audio. And it looks like we do need to remove the screw by the RCA jacks, because if we look at the back, we can see inside this foam there's something that comes through and solders straight into the board, and I suspect it's one great big chunky set of connectors. And at a minimum we need to remove this wire as well, because we won't be able to remove the board and flip it over. These red and black wires go to the speaker output, so they'll likely be a good candidate for desoldering later. Let's not do it quite yet though, because I might be able to get away with leaving them attached. Let's see how much leeway we have when we try and pull the board away from the back plane. And at first it doesn't want to come, because it's, well, glued. But by snapping bits of the board off out of their epoxy glue, I can feel that the board does want to come away, but it's still held to the back panel by the foam, which must be glued down. It's time for an incredibly sharp knife. I'll use this craft knife with a flat tip to go around the outside of the foam and gently cut away at the adhesive. It's not going to be perfect, and if I go too far in I might damage something, but I'll go nice and slowly. As I'm going along, I can feel the glue giving way, and I keep pausing just to test and see if we're on the right path. Some areas are easier than others to cut around, but I think if I can get most of it off, then we'll be able to remove the foam at least from the back panel. This isn't the easiest job, but I do think I've picked the perfect tool for this. And progress is quite quick, despite me having to stop for a while because I became grievously wounded. Ow! As the foam's cut away, the board naturally starts to fall away from the back panel, which is really good news. One final push, and the foam is free. But that does mean that because we've got the power connected on one side and the speaker on the other, we'll have to desolder one side. I vote for the speaker output wires because they're a thinner gauge and a lot easier to desolder than the power cable. At my general temperature of 340 degrees Celsius, the solder melts and releases the wires very easily. I really have to remember to wire these up the right way round when I replace them, or I'll get an inverted stereo signal, and that would suck. So with those wires desoldered, I should be able to move the board away from the back panel in earnest. The power cables are still connected, and I don't know who Ernest is, or why I'm examining his back panel. This is a bit messy, but we should be able to just re-glue it. And I think I need to further remove this foam from the PCB so I can solder. Annoying. And I've also just spotted a 3842B PWM controller, another common source of failures, so we'll have to keep an eye on that as well. I can't use the flat blade to remove the foam from the PCB, otherwise I'll risk chopping the components off, and that would be bad. So we're going to use some heat and heat up the glue until it gives way and we can pull the foam off. The hot air station's only set to 100 degrees here, so by the time it hits the board it's probably around 60 degrees, which is enough to weaken this double-sided tape and allow me to pull the foam off, and once it's off it can be reused. Foam like this is to prevent high-frequency sound leakage from inside the speaker cabinet. It does seem a bit overkill though, they should have spent that money on the capacitors. And speaking of which, here's my first error. This is a crossover capacitor, and it's non-polar. Unfortunately, I've ordered a polarised capacitor for its replacement. A crossover capacitor allows only high frequencies to pass to the tweeter in a speaker, so it's not critical to the function of the speaker, just the way it sounds. So hopefully this capacitor will be okay, at least while we're testing. A little wiggle to break the epoxy potting, and the capacitor comes free. Because I might have to use this in the interim, I think we'll go ahead and test it straight away. I'm really hoping it's at least serviceable. Anything over an ohm and we're stuffed. And that's within the plus or minus 10% spec on capacitance, and the ESR or equivalent series resistance isn't too bad either. I do actually have some good crossover caps of the right values, but I can't use them, and I'll show you why. Although they are the right value, when you take them over to the PCB you see there's absolutely no way we could make them fit. Never mind, we can use this one for now. We'll pop it back later. The other cluster of capacitors needs to come out as well. By using a mixture of intuition and the force, I can determine that the leads we need to desolder are here on the underside of the board. And I'm entirely sure you don't want to watch me desolder every single capacitor, so I'm going to do a combination of speeding up the footage and just cracking on. This second capacitor does not want to come out. I thought it was the potting holding it in place, but no, one of the leads isn't actually removed properly. So I gave it another blast with the desoldering gun. And then, as if by magic, it came out. Ta-da! I'll pop these all to one side so we can test them at the end of the video and see which ones were really faulty, rather than just the obviously visually faulty ones. Because this is a modern device, the components are all soldered in using unleaded solder. It's not my favourite alloy to work with, and it's a lot easier working on retro systems. Some people are under the misapprehension that leaded solder is banned, and that's not true. Leaded solder is just prohibited for use in new products. This is the capacitor that's clearly faulty. It's come out of the holes, but it's stuck to the inductor next to it. This is a cap top 25 volts 1000 microfarad that's allegedly rated for 105 degrees, probably at 2000 hours. I doubt that seriously. Knowing that this one was stuck to the inductor next to it, I assume that the other one in the pair is, so I go for it with my flat knife. trying to save myself some hassle later. And out it comes. Now, if any capacitors have been cooked inside this speaker, my money is on these small ones. Smaller capacitors usually dry up through heat first because they have a lower internal volume of fluid. Fellow retro repair veterans may have seen what looks like a crack on this capacitor here. But fear not, it's actually just a dribble of potting material. Using Finley the flat knife, or I'm going to call him Finley now, you can scrape it off. And because some of these capacitors don't want to come out easily, I'm adding some extra solder to the pins before I desolder them. I know this sounds counterintuitive, but it allows the desoldering gun to get more suction on the leg and a better draw. And just a further note for the faint-hearted, I'm not rubbing my tip on the board, I'm just moving the legs around so I can get better access. But for some reason, I can't seem to desolder these capacitors. Then I realised that my tip is completely clogged. So I slip my tool inside the tip and clean it out. After that, Bob's your uncle, Fanny's your aunt, and Steve's the bloke who drives the dust cart. Things start going a lot more smoothly from here on in. Ah, a nice clean hole. These parts are falling out due to gravity. If you're looking for an effective tool for reworking electronics, you can't go far wrong with a desoldering gun. It's just such a time saver. With those holes cleaned up, it's time to move on to the last couple of caps. This one's nestled in between some other components, but it shouldn't be too difficult to remove. It's these two leads here. And again, we're going to add some extra solder to help the desoldering gun clear those holes. The advantages of this technique are that you get a better draw on the lead, you get better heat transfer through the component lead and the via. The disadvantages are that you can end up filling the chamber on your desoldering gun a lot more quickly. Of course, no one technique is perfect, so it's best to have a variety of approaches when you're desoldering things from a board. I had to rework the legs on this capacitor a couple of times and eventually it fell out. It took me a minute to spot it. Once again, this is a smaller capacitor, and we know that their lower volume of fluid can leave them more prone to death by heat. Conversely, larger capacitors often survive heat a lot better. The larger amount of fluid inside them means that they take more heat to boil. I'll place bets that even this rubbish capacitor is going to be okay when we test later. So why am I replacing it? Well, it's CapTop, a brand I've never heard of, and you can't find a website or a datasheet for them, so I have no idea of the pedigree of this part. And if I'm going to do the work, I don't want to do it more than once. This potting will need to be broken away, but the capacitor should pop straight out. And there we go, that was easier than I expected. Okay, so all the capacitors are now out of the board, it's time to put our new ones in place. Before I go to the hassle of soldering new capacitors into all of these component locations, I'm going to test them with the same ESR meter that we used on the old capacitor. I always like to make sure that my new capacitors are good, and there's even fakes out there. But our new cap passes the test with flying colours. All I have to do now is liberate its brethren from this bandolier packing, and we're off to the races. The negative lead on a capacitor is marked with a minus sign. Its leg is also shorter than the positive lead. And obviously, polarised capacitors need to be installed in the correct orientation. On the PCB, the negative side is marked with a cross-hatched section. Once both the leads are through, I spread the legs. This stops the part slipping out of the holes when I'm getting ready to solder them. The second capacitor is looking tip-top as well. Hooray! Once all these capacitors are replaced, we can check if there are any more faults on the speakers, but I'll be honest, I really do suspect that it's just the capacitors. This PCB, like many modern boards, is particularly difficult to solder on. Modern PCBs are often machine soldered in factories. That's why I'm often aghast when people suggest to newbies that they should practice their soldering on old motherboards or modern equipment. It's really not the same as soldering a Commodore 64 or a ZX Spectrum. That being said, please do not practice soldering on vintage machines. That's not what I'm saying at all. Just soldering modern boards really isn't a good way to learn. So that's our first two capacitors in. I'm going to jump ahead and solder the rest of this section in right now. Having checked, my potting has all dried up, so I'm going to have to leave these capacitors unpotted for the moment. Let's crack on and do these last two capacitors. This big boy was quite expensive. I'm not even really sure if I needed to replace this one, but now I know that a good quality capacitor is going into the board. Bigger capacitors often have higher thermal mass, so they can be a bit more difficult to solder. The leads and pads often take more heat to thermally saturate, meaning a longer dwell time. But that's good enough for me. Always wear safety glasses when clipping your leads. So that's every other capacitor replaced except for the audio crossover cap, and unfortunately it hasn't arrived. So we're going to have to do what I didn't want to do, and put the old one back in. Which makes a bit of a mockery of me moaning about cap top. I have tested it though and it is within spec, so let's pop it back in, at least for now. And yes, it does pain me to do this. Let's go for it then. Lisai. With a non-polar cap there's no negative or positive leads, so any way around will do. At least it's nice and easy to solder in, I suppose. I'm getting tired now and my soldering's getting ham-fisted. Okay, that's going to do because this cap is coming out sooner rather than later. And that's it, it's all soldered up. All the capacitors are in place and the speakers should now either work or reveal another problem. We're going to have to put this back together in earnest. I still have no idea who Ernest is or why we're going to put it back together in him. But I do know I'm not going to bother gluing this back together yet, because I have to replace that other cap. Because we're dealing with AC voltages here, I'm going to have to put it all back together before we can test it. So why not let's go for it. Let's put every screw and everything back together without even knowing if it's going to work. Because that's how we fly, by the seat of our pants, here on Mark Fixes Stuff. I hope you're enjoying this video. If you are, perhaps you consider becoming a patron at patreon.com/Mark Fixes Stuff. Your support will help me make more videos and continue on this retro, or speaker fixing in this case, journey. My patrons are the driving force behind this channel, so it's something that I really appreciate. Making sure to get the right wire on the right terminal, we solder the speaker output wires back in position. And with those reattached, it's time to slip my hands inside the box. From memory, I rewire the board. I'm pretty sure it's correct though, because the potting marks all line up. It's about this point in the process that I start to regret not testing this before I've put it all back together. But because this isn't a video, actually laying out an AC powered device and plugging it all in might draw criticism, and I don't want people to criticise me. I want them to love me. Love me as one of their own. And with the last screw in, it's time to test. Now obviously I'm not at my editing PC, that's in a room that resembles a tiny broom cupboard. In order to test our speakers, well, first we'll need to wire them up, so I'll get the red and black wires from the passive speaker and pop them in securely into our speaker output terminals. With our wire securely clamped, it's time to put some power into the back of our main unit. I'll be using an iPad to test this, so I'm plugging into the RCA connectors for the unbalanced input, and the other end of our cable plugs into the iPad. And of course we'll need some power, so let's plug that bad boy in and turn it on. When we started, our speakers gave no sign of life, so let's see if we can get a power LED. And that blue light is good news. The light wasn't turning on before, so obviously at least one of those capacitors was blocking the power flow. Turning off and on again, we still get the blue light. Fantastic. But do we have sound? And that's a question we can answer by playing one of my absolute favourite artists, Ben Elson. Here we go. Outstanding, we have sound. I'm so pleased, I can't begin to tell you. But now our speakers are working, it's time to test those old capacitors and see what kind of a state they were really in. First up is the obviously failed capacitor. Connecting up the leads and pressing the button, the test will start. And that's only got 10% of its capacitance and a whopping 5.2 ohms of resistance. That's just definitely a bad capacitor. Next up, the same capacitor value but a little bit further away from the heatsink. And that capacitor is actually spot on. Now the 400 volt 100 microfarad part, which passes, a very fiddly 470 25 volt that I tested multiple times and failed, and then another one of the trio of caps which were near the failed cap, and all of these failed. I did test each cap multiple times to make sure the crocodile clips weren't possibly touching. But these caps all failed. Maybe it was the heat or maybe a dodgy batch, we'll never know. The 470 microfarad 25 volt capacitor just about squeaked in. But this small 100 microfarad 16 volt capacitor also failed, as did its partner in the board. So all these small capacitors ultimately failed, and it might be down to heat, a bad batch as I said, or it might just be that they're crap. So quite a few of these were bad, but we have rescued the speakers. Granted, it needs a new crossover capacitor and that's something I'll revisit, not in a video, but I can now go and edit this video using these speakers. Incredible. Massive thanks to my amazing patrons for helping me on my retro journey. You too can become a Mark Fixes Stuff patron by going to patreon.com/Mark Fixes Stuff. You'll get ad-free early access to all of my videos, as well as some exclusive vlogs and access to the Patreon exclusive Discord. You'll also get the ability to transform into a puppy. That might be a lie. Anyway, that's about it, so see you all later. Bye.